Hey, good morning, class. So today I want to talk about 6.2, solving right triangles. So you'll see that in a minute with the PowerPoint. Okay, so here's the lesson. So let's take a look at that. So 6.2, trigonometry of right triangle. So we do know that's a right triangle with the little square down the bottom with all three sides. Okay, so one thing that you notice, so if this one, the base angle is capital A, so that means the cross segment would be considered a little a. And then same thing happened with the rest of the side length. So capital B here with the angle. So that means the one facing across. So the corresponding segment would be segment B, or you can say segment AC. And then over here, so side length C, which is the hypotenuse. Okay, so we'll take a look at that. And that's something we talked about in chapter 5 already, SOHCAHTOA. But instead of using that opposite adjacent hypotenuse, we just want to call this one a little bit differently. So the base is called x, the height it's y, and then the hypotenuse it's r. So cosine of theta, which is considered adjacent over hypotenuse, or in other words, it's x over r which is the radius, and then sine theta, sine of theta, so y over r, tangent of theta, y over x. And then the rest of the ratio, they're just considered the reciprocals of cosine, sine, and tangent. Okay, so take a look at that. Secant, it's just the reciprocals of cosine. And then cosecant is just the reciprocals of sine. So that means you just swap the number or the element, top and the bottom, numerator, denominator. And then tangent of theta, it's just the reciprocals of cotangent. Or cotangent is the reciprocals of tangent. Okay, so now let's do one problem like this. So find the values for A, B, and capital B. So capital B, that means segment angle B. Okay, so one thing that we notice, we do know the base angle is 40, hypotenuse is 12. So that means we can use all those ratios, such as cosine, sine, and tangent. So the one, in order to solve for A, so this one is considered opposite. We do have opposite, hypotenuse, and then the base angle. So that means we need to apply the ratios of sine of theta. So sine of 40. Okay, so using SOHCAHTOA, obviously we're using sine because that involved with opposite over hypotenuse. So by plugging a number, so sine of 40 equals A over 12. And then cross multiply, so sine of 40. So multiply by 12 both sides, and then you just want to do that on the calculator. So 40 is a non-special angle, so you have to do that on the calculator. So that's sine of 40, it's 0.6428. And multiply by 12. So this one is about 7.735. And now you want to find out the rest of the segment here. So for segment B, so this time we're using either cosine or tangent. Doesn't really matter. Again, cross multiply or just multiply by 12. The other ones, so it's 9.1925. And what about for the other one here? So tangent 40 equals 7.7135. So divide 7.7135 by tangent of 40. Again, you can just do one thing at a time or the scientific calculator, or you can just put everything into the graphing calculator. And now here's what we got. It's the exact same thing. So it depends on which way that you like. And now, how do you find the measure of that angle B right here? So we can use that, the triangle sum theorem. Complementary angle, maybe. So 90 minus angle A. So 90 minus 40. So we do have 50. So here's what we found. Okay, so now here's another example. So we do have a right triangle, A, B, and C. So A equals 2.73, B is 3.41. Those are just the line segment. Find the remaining sides and the angles. So the one that's given here, this one is considered angle, well, it's a side, angle side. So we do have two segments given already. It's a 90-degree right triangle. So let's solve for angle A first. So in order to find out angle A, we need to find out the matching ratio. So the one that's given, it's opposite and adjacent. So that means we're using the ratios of tangent. So tangent of angle A, it's opposite over adjacent, is 2.73 over 3.41. Divide it first, so we do have 0.8006. Now the one that we found, this one is just a ratio, it's not the angle. So what we need to do, we need to take the inverse of tangent of 0.8006. So either you can do that on the calculator or you can use the trig ratio table online. So according to that online, so 0.8006 is corresponding to 39 and 38. So we want to take the angle right in between. Or do that on the graphing calculator, so that's about 38.7. So the way to do that on the calculator is more accurate, it's more precise. So I do recommend you to do that on the calculator. If you try to use the trig ratio table, I mean you can, but sometimes the answer would be a little bit, it would be slightly a little bit off, okay? So got to be careful with that, the solution. So the one that we found, take the inverse of tangent, so type in 0.8006 with the scientific, and then second, and then tangent, and then enter, or the equal sign. And now, what about for angle B? So we do know that it's a 90-degree triangle, so 90 minus 38.6, the one that we just found, and then we end up with 51.4 degrees. And now we need to find the third side. So for the third side, so a lot of people might be wondering, we can use the ratios, sine, cosine, or tangent. Certainly you can. And also you can use the Pythagorean theorem. Okay, so try to use the Pythagorean theorem, a squared plus b squared equals c squared, and solve for c. And you got 4.37. So here's another problem that I can try. So right triangle, so angle A, 42 degree, segment C is 15, the longest leg, and find A, so round the answer to the nearest 100. So this one I do recommend you to use cosine. Okay, so cosine of 42 degree equals A over 15. So eventually, once you found it, so this one is going to be about 10.03. So here's some of the word problem, but before we do that, so one thing I just want to go over, so that's something you learn from geometry. So for the angles of elevation, that means the angle measured from the horizontal up. So that means you're looking up. And then angle of depression, an angle measured from the horizontal down. So that means you're looking down. So here's the angles of elevation, looking upward. And here's the angles of depression. Again, this one, the lines, it's always flat. And you're looking downward with the angle right between those rays right here. So now, here's one of the word problem. So if a 75 feet flat pole casts a shadow 43.0 feet long, and what's the angles of elevation of the sun from the tip of the shadow to the nearest hundredth? So one thing that we notice, according to the diagram, we do know that the flagpole is 75 feet. And the angles, we don't know what that is. But we do know the length for the shadow is 40.0 feet. So we do have opposite, adjacent. Guess what kind of ratio that we need to apply for this? That's right. It's going to be tangent. So using tangent, so we got tangent of theta, so that equals 75 over 43. So the 0.0 doesn't really matter. So that one is about 1.7442. But again, this one is just a ratio, it's not the angle. So we need to take the inverse of tangent of 1.7442. So typing that on the calculator, so second inverse of tangent, and then 1.7442, and then press enter. And here's what we found. So 60.17 degrees. Okay, so now here's another one. So a man climbs 213 meters up the sides of the pyramid and finds an angles of depression to his starting point. It's 52.6 degrees. And how high off the ground is he? Round to the nearest hundredths. So 2 decimal places once again. So one thing that we notice, so this one is the angle of depression. And hypotenuse is 213 meter, or you can say that's the slender height of the pyramid. And then x, the actual altitude or the height of the pyramid. That's what we need to find out. So this one is the base angle, this one is the hypotenuse, and it looks like we need to find the opposite. So that means we need to apply sine of theta. So sine of 52.6 degrees. Okay, so those are the given information. Opposite over hypotenuse, so which is what? Sine theta. So sine of 52.6. So it's x over 213. Cross multiply or multiply everything by 213 meters and then put in everything to the calculator. So here's what we found. So it's about 169.21 meters. Again, rounded to 2 decimal places, to the nearest hundredth. And how do you check your work? The way to check your work, you can just by plugging a number back to the original form. And you can say that hypotenuse is always longer than the opposite or the adjacent. Well, it is, right? And here's the one you can try. If the angles of elevation of the sun is 75 degrees, how tall is the post that casts a shadow 1.5 feet long? So it's quite similar to the previous problem that we did. Tangent. And then cross multiply. So that's what we found. So here's another problem. So Mr. Wilson wants to know the height of the flagpole, but he can't find the distance between him and the pole because there's a fancy fence in the way. The angle of elevation from the top of the pole to where he is standing is 61.7 degrees. So he turns 90 degrees and walks 25 feet to another point. And his new spot creates the angles of 54.5 degrees from his old spot to his new spot to the flagpole. That's very complicated right there. And how tall is the flagpole? So the problem is that there's so many information involved. And anytime that I deal with so many information with the word problem, again, one of the strategy, you want to highlight the key word, the key factor, the key number. So there's so many key number right here. So we do have 61.7 degree, and the guy turns 90 degree angle and walks 25 feet. Okay, so make sure that you need to highlight all the information. And then he's created the angle 54.5 from his old spot to the new spot. Okay, so the most difficult part of the problem is by setting up the diagram. So here's the diagram. So it started with point A, and then he walks 25 feet to point B. Okay, so here's the one. And then he created the angle 54.5 degree. Okay, so one thing that we need to find out, we need to solve for x first. Once we solve for x, so we can find the height of the flagpole. So in order to solve for x, so we need to use tangent, because the bottom right triangle here is considered opposite and adjacent, and the base angle 54.5 degree. So this one is like two-step problem. So first thing, we need to focus on the bottom right triangle here, the flag triangle. Okay, so started with that tangent of 54.5, so that equals x over 25. And then once we solve for x, so it's 35.0 feet, and then we use that as the adjacent, so we can just find the height of the flagpole. And then for this cross-section triangle here, so we can use tangent again. So tangent of 61.7, so that equals the height over 35. And then cross multiply, or just multiply both sides by 35, so 35 times tangent of 61.7. So here's what we found, 65.1 feet. And that's the height of the flagpole. Okay, so that's it. So that's all the lecture video for 6.2. So anything that you're kind of getting stuck, you can always rewind or fast forward and take a look at that again. And thank you for watching the video today. So I'll see you guys next time.